board member and CRO at a company called Mavericks that has a DevSecOps platform. But the topic today is really plug and play DevSecOps. Can it be done like that? Can it be done that simply, plug and play? How to quickly implement DevSecOps and accelerate security to the speed of DevOps. So if we look at the evolution that development has gone through from waterfall to agile to DevOps, we all know that developers can really assemble their application and deploy it into production several times a day. Well, they do run sprints and they release into production probably every 2 weeks. Still, security today is often challenged to discover all security vulnerabilities within this time frame and hand them over to development on time so that they could fix them. So if your security takes, let's say, a week to discover security issues and then validate whether those are fixed or not, so which means in the second week of sprint, if we find security issues, they will not be resolved on time and they would slip into production. And that's a big problem because really you don't have security posture of your application under control if security is not running as fast as DevOps. Now, companies are deploying now application security tools, in short, AST, and there is actually a variety of different types of tools available on the market, and they all do different things. The most popular are static application security testing that reviews the code itself. Open source analysis and software composition analysis are looking at what components are used within the code and their vulnerability status. Dynamic application security testing is like automated pen test and is another very popular category. But there are other categories like container and Kubernetes security. How can you bring penetration testing results into your DevOps environment and others. Now, the challenge starts when people want to integrate this application security tools into their DevOps environment. And so here we will look at what is happening in a little bit more detail. On the bottom, you see the classic simplified DevOps process where there is a code and then this code is checked in, a build is created, it's deployed, it's put in a test environment, and then maybe released to production. So it's what we know, continuous integration, continuous deployment. And on the bottom, developers are taking tasks or issues or bugs, right? Developing or fixing them and releasing as new code version. That's on the bottom, the classic DevOps process. Now, security has its own process. And now when the security tools are added, the first thing need to happen is that the security tools are called for a scan at the right time within this CI/CD process. So for example, SaaS tools can be called as soon as the code is checked in. This diagram is simplified. OSA tools are also called at the beginning of the CI/CD pipeline. Now, when this tool should be called to do a scan, each of these tools needs to know which code version to test or which artifacts to scan. And so that information need to be passed to these tools. Also, these tools have different types of scans. It can be a short scan or a full scan. So that need to be configured. And that becomes a challenge. So you either have to do it manually for each scan, which is undoable, or you have to write scripts to pass on that information from CI/CD to each of these tools. And then you need to start maintaining the scripts. So it becomes a huge challenge. The next challenge here is for security team to go and review the security issues that are discovered by each of these tools, because typically very few companies would have only one tool. Most will have 2, 3, or 4 in this environment. And so now the security issues are stored in each of these tools individually, and you have to go to each of them to find which is important, which is priority, and then juggle between them. So also becomes a manual process, and which means it is a slow process. There is one more challenge here, that these tools have out-of-the-box integration with defect tracking systems like Jira, for example, and they all claim we are ready for integration with DevSecOps. But what in most cases this integration means that when this AST tools, they discover security defects, they will dump all of them into defect tracking. And so what it means that developers will be overwhelmed with a number of security defects that are not filtered out, not prioritized, not grouped. And so it's really that integration is useless in that sense, and you need to actually stage the security issues somewhere, ideally in one place, before you submit them to defect tracking. Now, these are only few out of many other challenges that exist in this environment, and I can talk about those in more details if there is interest. But let's jump fast forward to the solution here. Now, there is an app for that, for DevSecOps, and the message here is that there is no point of building DevSecOps from scratch, writing custom code, because it is a very complex undertaking. The moment, even when you have one application security tool, you already need to still have a staging environment to work with those security issues and prioritize them. The moment you have two, you need to correlate issues between them, and you also need intelligence. And so this is what this category of tools bring. They serve pretty much as a DevSecOps platform out of the box, providing what it's called orchestration, correlation, and intelligence capabilities. In fact, Gartner has been tracking this for several years, so I think 3 or 4 years actually, in their hype cycle for application security. So generally speaking, it's a known product category, but it's not yet widely used or known on the market. Now, what ASOC tools bring is a number of out-of-the-box integration for majority of AST tools, most commonly used. You see the common names on the right side. There is a lot of different categories, like we talked before, and a variety of products, but all of them can be just integrated within a few hours or days into an existing DevOps environment, which on the left side you see consists out of CI/CD tools, defect tracking tools, source code repositories, software artifacts, and container frameworks if it's a container environment. So all of this integration would be available out of the box, and if there is a new tool, it can be added within a matter of a month or two. Now, with ASOC tool, what happens is that orchestration capability now front ends triggering each and every scan. And so the DevOps CI/CD pipeline will have just a small code snippet incorporated at each needed stage within the process when it gets to the right point. So it will be just a small code snippet added there to call orchestration engine of these tools. Now, the tool, then the ASOC tool, from there will know which code version is part of the CI/CD pipeline. Where are all artifacts located? And so it will pass on that information to the tool automatically. In fact, orchestration automatically builds and configures security CI/CD pipeline within the tool and executes them. And so now when orchestration does its job and security tools have completed their scans, correlation comes in, which collects security issues from each of the individual tools in one place and allows security team to go to that one place, see the full list of all security issues. Modern tools even have AI capabilities to detect if certain issues look like false positive and determine probability ranking for that. And false positives, as we all know, pollute this whole list quite a bit. So automated discovery of those helps quite a bit. And then there are other things that you need to do here to sort of group issues probably together so that you can, if they are part of the same piece of code, then you would want to submit them as one group to developers for fixing. You obviously will want to prioritize and select which ones go to development so that they are not overwhelmed. And then the intelligence capability is also pretty important. Now this system, as you can see, will have all information about the code repository. It will know the lines of code. It will know which version of the code has been tested. And so it creates a data warehouse with all this data that allows collection and real-time metrics and reports. And so this is kind of a subset of metrics and reports that this tool can collect. It starts from general sort of software assets data available for this application or for a portfolio of applications. It will know all the source code, lines of code, and then it will be able to track security technical debt, which is all vulnerabilities found in this application and not yet resolved. But it will be able to calculate more sophisticated metrics here, like vulnerability open rate, sort of in a release, how many new vulnerabilities are created, vulnerabilities escape rate, how many of those that got created during a sprint or release, they end up in the production environment, and how many are resolved. So that way you can start seeing, are you really able to resolve all those new vulnerabilities that are created during the sprint. There are other very useful metrics like open to resolved ratio, and then further mean time in production, mean time to detect an issue, and mean time to resolve. That's what I was talking earlier. Your mean time to detect the security issues should be a matter of a day or two maximum to run the complete scan. And then mean time to resolve is a metric related to development, how quickly they fix those defects. And then security, you need to be able to run a scan within a day to really validate that security issue has been resolved. And so with that, I think this is the end of this quick overview. And so hope it was helpful.